Okay, so now I'm just going to basically graph this reciprocal of a quadratic. Now, for this video, I'm going to make a few cuts in the video, so I'll just explain what I'm going to do, and then I'm just going to cut to the next scene to save time. So basically, first thing I'm going to do is going to factor everything. Okay, so to save time, I just did all this work off the camera. So basically, I believe the last thing you saw was just the initial equation. So the first thing I did was I factored anything I could. So it was, in this case, it would be the denominator. So negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. So these are the factors. And the next thing I did was I just found my vertical asymptote. So I did that by setting all my factors equal to 0. So when we do that, we get x equals 5 and x is equal to negative 3. Don't know why I didn't write that. So these are the vertical asymptotes. The horizontal asymptote, so as we learned in lesson 3.5, if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0. Now notice how, for the x-intercepts, notice how first of all we don't have any factors in the numerator, but notice how if we have a horizontal asymptote at y equals 0, there's not going to be an x-intercept, because there's a horizontal asymptote at y equals 0. No x-intercept, so I just didn't write that to save space. For the y-intercept, I just plugged in 0 for x, and I got negative 1 over 15. And since we have two vertical asymptotes here, we're going to have a local max or min point. So what I did was I just found the average of the vertical asymptotes to find the x value of the local max or min, so we get 1. And then I plug in 1 into this equation to figure out the y value of the local max or min. So then you get negative 1 over 16. So now what I'm going to do, since I have all of this information, all I need to do now is create a number line so that I know when the graph is going up or when it's going down, and I can just graph it. So this is the graph I made, but I'm going to create a number line quickly here. Okay, so now I created my number line, and when I plug in a value that's in between negative infinity and negative 3, I got a positive value. So I know that the graph is positive in between negative infinity and negative 3, and I did that for all these intervals. So we have negative here for negative 3 and 5, and positive here for 5 to infinity. So now what I'm going to do is I'm going to plot all this information on the graph. So we have we have a vertical asymptote at x equals 5. So I apologize, I don't have a ruler here, so this is going to look really messy, but this is supposed to be a 5. We have vertical asymptote at negative 3. Okay, and now we want to plot our y-intercept. So this is going to be here. And now notice here how since it's negative here, between negative 3 and 5, the graph is going to be below 0. So we know that if this is going to be a local max or min point, well, since between negative 3 and 5, it's negative, since that means it's going to open downward, it's going to look like this. We know this is going to be a local max. So we can say at 1, so 1's going to be about here, maybe. So we can say 1's going to be about here, and negative 1 over 16 is going to be a little higher than 1 over 15, negative 1 over 15. So like maybe this is where our local max or min point is. And then yeah, we can just, it's going to be a quadratic, so it's going to open downward. So we can draw this. Actually, no, my apologies. So since once you do this enough times, you just know how the graph's going to look like when you do the number line. Basically, this is what the graph's going to look like. It's going to look like this. This is what the graph's going to look like. Now, why? How do I know that? Well, from negative infinity to negative 3, it's positive. So we know that the graph in between these two areas is going to be positive. So that's why from here, negative infinity to negative 3, it's above y equals 0. It's positive, the graph. Same thing for 5 to infinity. It's above 0. And for here, it's negative. It's between negative 3 and 5. and it's negative, it's below 0. But I only know this because I've done it so many times, but to truly prove my understanding of it, how do I know it's going to look like this? There are two ways you can do it. One way is transformation, so you would create a parent function of this reciprocal function, so 1 over x, and then you would create another table and apply all the transformations to that table, and then you could just plot the points out and graph, and it would look exactly like this. The other way, that's, in my opinion, it's a little more quick, and it's the way we were taught in class, is we can create a table of values to show why the graph specifically looks like this and looks like this. Now, for time's sake, I'm just going to do it for one of them. So I'll just do it for this area. So basically, what we can do is we can create a graph. Now, notice how this vertical asymptote is x equals -3. So what I'm going to do is I'm going to just plot some random x points, but I'm going to plot them so that they're very close to -3, and they get closer to -3 as we go down. And what I can do here is I can plug these points into this equation and see the behavior of the function. So when I do that, it's going to take a little bit of time here, so I'm going to fast forward. So notice how I basically just plug all these values into this formula. So notice how as we get closer to -3, as we get closer, each value gets closer to -3, each value for f at x increases. That makes sense. At -3.5, so maybe about here, this is supposed to be 0.23. -3.1, that's a little closer to -3, so we're going to move here. 1.23, the value is greater. And at -3.01, so that's almost touching -3, but it's not going to touch -3 because of the vertical asymptote. It's 12.4. And as you can see here, it's going up. So that's how we know the behavior of the function is like this. Now I'm going to make a graph. Same thing, just I'm going to prove to you that I'm going to prove why it looks like this as well. So down here. You can make a graph like I did for this to show why it looks like this down here. But a better way, the way I like to do it is I just like to plug in a huge number, and you'll see why in a sec. So let's say, since we're going negative here, I'm going to plug in -100. So when I plug in -100 into this equation, I get 0.000098. What does that tell me? That tells me that even though I plug in -100, which is all the way over here on this graph, we're still not going to touch 0 because of the horizontal asymptote. So that's why we know the graph looks like this. It goes down, and it keeps going this way, and it keeps getting closer to the horizontal asymptote. So as it goes this way, it keeps getting closer to the horizontal asymptote, but it never touches the horizontal asymptote. It's 0.00098 and -100, which is all the way over here. So that's how we know the graph looks like this. And if you want, you can make tables, and you can do this for this and this as well if you want, but just for time's sake, I only showed this for this part of the graph. So now, we're almost done. Okay, so now, since we graphed this, it's very easy to state when our graph is increasing, decreasing, and when the graph is positive, negative. So, when is it increasing? Well, as you can see, from all the way to -infinity, it increases up till -3. And notice how there's a circle bracket because -3 is a vertical asymptote. So it's increasing here, and it's also increasing from -3, but not at -3. And it increases all the way to 1. Sorry, this is 1. This is the point 1, right here. It increases from -3, it's increasing all the way to 1. Now notice how there's a circle bracket for both. Circle bracket for -3 because it's a vertical asymptote. And it's a circle bracket for 1 because at 1, it's not increasing anymore. It's not increasing at 1. That's why it's a circle bracket. And then for decreasing, so same thing, 1 to 5. 1, it's a circle bracket because it's not decreasing at 1 either. It just, at 1, it's doing nothing. But then after 1, it decreases. And circle bracket for 5 because 5 is a vertical asymptote. And it's also decreasing from 5 all the way to positive infinity. It's decreasing. When it's a positive, this is pretty straightforward. Well, it's positive from negative infinity to negative 3 because it's above 0. And it's positive from 5 to infinity. It's above 0. And when it's a negative, pretty straightforward. It's negative from between negative 3 and 5. See, it's this part here, it's below 0 between negative 3 and 5. And I thought I should just quickly mention the domain. So sorry, my phone stopped recording because I was running out of storage. But anyways, our domain, f can be anything, but it can't be negative 3 or 5. And y can be anything, but it has to be greater than 0, as you can see here. Or it has to be less than or equal to negative 1 over 16. Remember, negative 1 over 16 was our y point for our local maximum. So as you can see, it has to be below that. Can't be above that when it's below 0. So yeah, this is the answer.